introduce my guests. So a familiar face, JRB, joins me on Daily Stories and Chill often. And he been helping me a lot with the feature neutralization, scripting and coding, and kind of figuring out the logic behind it all. But since we did the last special where we talked about different linear regularization methods to achieve feature neutrality, one of the last remaining topics really is the feature exposure clipping tool. That's what I've named it, by the way, Michael. The feature exposure clipping tool that Michael Oliver posted in the forum in JRB's forum post. So it kind of went untouched for a long time. It was posted September 20th of 2020. Here's the link to the forum. I'll put it in Zoom chat too. So I posted that link everywhere. And it just kind of sat there. I don't think very many people implemented it, but it was something that I was very interested in, because what I found out that happens is this feature exposure clipping tool leaves coefficients alone if the exposure is below the threshold that you establish. Whereas the OLS methodology potentially touches every coefficient to achieve the desired amount of feature exposure that you choose. So I'm very interested in that. Michael Oliver, can you just give me the motivation behind this tool that you created?
Yeah, I mean, the motivation was basically, like, as you were saying, you might want to keep some feature exposures, especially the smaller ones, and reduce the risk from some of the larger ones, where if you're just doing OLS, you're going to be reducing everything. And it also lets you gives you a better target. So if you do sort of the regular OLS feature neutralization and you choose like a proportion of like 0.5%, you don't know what your max feature exposure is going to be after that.
Right.
And so this just sort of lets you control it more finely, and so you know your max feature exposure is going to be a given number. Granted, it's a little bit different whether you use this. It uses Pearson correlation, and I think that we've moved to using Spearman, but it still gives you a little bit more fine-grained control.
So I like it a lot. I've tried it out. It's a little slow if you're on CPU only, but that's okay, because I'll explain why that doesn't matter so much anymore. That's how JRB is really taking this and turned the dial up to 11. That's putting the bow on it and dropping the mic. That's what JRB did. But I want to ask you, how did you come up with the threshold that you provide in the example code of 0.1 as a maximum feature exposure?
I tried like 5%, 10%, 15%. I think anything 15% or below is probably a good place to be. 5% is going lower than 5% makes it even slower and doesn't seem particularly worth it. 10% just seemed like a good compromise. But yeah, I encourage people to try different things and see what works for them. I was running for a while 3 models, one at 5, one at 10, one at 15, just to sort of compare.
Yeah.
I found that at 15%, the models that, like, the average correlation is virtually the same. It doesn't really change very much and so if you start at like 28% or something, going to 15 doesn't really hurt that much at all, which is kind of nice. But
it doesn't hurt, or it doesn't help?
It doesn't hurt. It doesn't your average correlation doesn't actually go down that much, which is with feature neutralization, it usually does go down somewhat significantly. So
right.
Yeah, so
feels bad, man.
Yeah.
So, okay, that's interesting. I did do a little crawling of your model pages on the tournament. Mm-hmm. And I believe Neum is not feature clipped, but MDO...
It is now. Yeah, it's now. Neum was the 15% one.
Okay.
Yeah.
So that's like your baseline model. And then you have Neum and MDO. I'm sorry. Now I'm getting confused. NMRO or MDO are 0.10 and 0.05.
Yeah, exactly.
Okay. So this is in the wild. This is in production, and you can look at it.
Yeah, it has been since basically that post.
Okay, so that's quite a long time series. That's very interesting.
Yeah.
What are you thinking about the 0.05 one?
It's pretty. I mean, it has, we're in a weird regime right now.
Yeah, it seems like it, doesn't it?
Yeah, all the neutralized stuff is doing really badly right now.
It feels bad, man.
Yeah. It was really good for a long time. And it probably will be good again. I think, yeah, I think 5% might be a little low of going for feature exposure. I think the higher things, like 10 or 15% might be a better place to be.
Yeah, I mean, I can just say from the videos we've done so far, talking about the example model having nearly 27% feature exposure. My own test in the Twitch example model, being basically a clone of the example model, deployed in compute at 50% neutralization and then at full neutralization. Yeah, the choice of threshold for 50% is arbitrary. So I don't have, I can't speak to its sensitivity analysis, but 100% is too much. 50%, I'm not real sure if that's too much as well or if it's not enough. And obviously the exposure for the example model clone is very high. It's 26%. I was running my own models at about 75% because it got me to about 0.1. It just worked out that way when I looked at my max feature exposure. However, I had a model that I built that I was feature neutralizing that was already a 0.1 feature exposure. And then I was reducing it further and I was hurting myself. And that was what I learned from this whole several month-long endeavor to explore and explain feature neutralization. I do want to just do a quick summary. Why do we do feature neutralization? Because feature exposure is risk. The more feature exposure that you have, the riskier your model is. The volatility will be high. You could experience much stronger burns. The unknown kind of among all of this is MMC, but that we have to save that for another day. Right now, we're talking about your feature exposure in relation to its correlation score. So Michael Oliver put this code out. I tinkered with it myself, hacked it, sliced it up, and I got it to run on GPU, and I turned it from like a 3-hour runtime to about an hour and a half, even on GPU. I told this to JRB, and JRB says, ha! I laugh at your slow speeds. Not really. But he spent a day or two. How long did you spend on that, JRB?
I don't know, maybe a couple of hours.
Okay, so we know JRB is at another level than the rest of us, and we thank him for his help. But he put it into TensorFlow. So I posted the link to the forum post, which contains the PyTorch implementation. That works. You can use it. You may need to tweak it a little bit for your use. But JRB graciously offered to write a notebook to release to the public that puts it on TensorFlow. I've tried it myself on CPU, on my CPU. I get a similar runtime as what I was getting on the GPU in the PyTorch implementation. But there's a kicker here. JRB, can you unveil the surprise that we're dropping today? The gift that you've given?
Yeah, so I think one of the problems was that you couldn't run it without a GPU before, and now you could possibly just run it once, and so it tries to cache the coefficients for each error. So Michael Oliver's code neutralizes the predictions on an error-by-error basis. And so, yeah, it caches everything to a job.web file. And so you could possibly put it on compute if you want to, and it'll still work, because it'll only have to predict, train a new linear model only for the live error every week. And it doesn't do much. You can still do it on a CPU in a couple of minutes, tops.
Now, I know some people have talked
really
about
slow
like
Amazon instances.
Yeah, I mean, of course, it's gonna be a little slower than what you get locally. Some people have talked about how they are running neutralization as a quasi cache. They're looking at the old prediction file from the previous round, comparing it to the new tournament file, and only running neutralization for the new eras that are present, era X, and whatever new test era is included, and then appending that to the bottom of the old tournament file and submitting that, since the rows don't change. That's fine and well. I think that's a sufficient method. However, yours does something different. It doesn't cache the actual prediction values. Yours stores the coefficients from the model itself and on a per era basis. Do I have that right?
Yeah, you just have to save 310 coefficients per error. It's fairly cheap.
It is. I'll tell you that my job-lib file that I have for one of my models is less than half a megabyte. So in job-lib file size, it is quite small. And since those coefficients are stored, it reruns the solution to neutralize each era and gives the same answer that it gave last time. And it checks to see if there's any new errors present in the file. So it doesn't store error X, which is the live predictions. And so it creates a new coefficient for that and saves the newest test era. And it does this every time it's called on. So that to me was like, wow, I'm not a sophisticated coder. I didn't ever think of doing something like that. And to me, this is like a tremendous gift to the community, but maybe that's because I don't know a whole lot about caching and those kind of principles. I posted the link to that notebook in Twitch and in Zoom.
Well, and then, sorry, go ahead.
I was just saying, in my production code, I've done something similar because it takes too long to run it every time.
Yeah.
I just basically use my old prediction file and fill in the new prediction file with all the old stuff except for the live era. So that's why I wasn't storing the coefficients, because I was just storing the predictions because I had the old prediction file.
Right. But now you don't have to save the prediction file because that's almost 50 megabytes. So now you're just downloading, you're running your predictions from the model, obviously, and then you're passing that through to the feature exposure clipping tool. So I posted the link to this notebook in both of the chat venues that we have, and I want to go through it. So let me just figure out the best way to do that. So I think.
Yeah, I was just about to say what I only learned this a couple of days ago. What Michael Oliver was doing is actually the next level to actually save your predictions, because it's very likely that your model is a lot more expensive to run inference on than this neutralization code. So caching everything is the answer.
I'm trying to figure out how to do this right so I can share on Zoom, but then my Twitch folks can't see it. So let me just sort this out, figure out how to best.
I can see your screen on Zoom.
I know you can see Zoom, but not everybody else can. So hold on, let me
let's check Twitch.
Hold on, I think I've got this now. So I'm gonna go to screen 2. Here it is. Now I have it. So everybody on Zoom should see the notebook, and yes, Twitch has the notebook. Okay, let's JRB, walk me through this so I can explain most of it. I'm gonna need some help eventually. We need a new version of TensorFlow. If you are lucky enough to have CUDA implementation, congratulations. I don't. I was afraid to break my XGBoost installation, so I did not run it on GPU.
But I got to start by saying something.
Sure.
There's nothing TensorFlow specific about this. So what I mean to say is that the torch also comes with a JIT. I think it's called torch script. So you could do the same thing with PyTorch and get similar results. So nothing special about TensorFlow here.
Okay. Yeah, that's fine. So, but this is a framework. I just want to say it won't work on Colab. So I did not make this a Colab notebook because of RAM issues. And I don't think, I wasn't able to get it around on Colab. I just kept it local. Download this notebook and you're going to have to modify some things to make it work for you. This is a framework. So this is not production code, but it's close enough that I think you can implement it. I made some notes for you to help you along, but we need to feed in the notebook where to find data. Okay. And so that's what the S3 bucket URL does. That's like the root. That's where all of Numerai's data is stored that we download from the API and whatnot. Or if you're not going to download the prediction file, you read in your own example predictions, which would be your model's predictions for the round that you're trying to neutralize against, right? So you just swap out the comments and do it your own way. And I left that in so that you can see how to do it. So we need to get the latest tournament data so we can neutralize against the features. And now this is the important line. And I tried to make it like as bold and as popped out as possible. Important, delete the file below. If you change models, you got to take that out. Otherwise, rename the file for your various models. Because if I run this on, say, the Twitch example model, and this is the name of the cache file itself, if I then try to run it on a different one or a different exposure number, it will just overwrite everything that's been stored and start from scratch. That's not good. Or it will take the neutralization that was saved already and implement it on a different model. And that's also very bad because each model should have its own independent run of feature neutralization. Okay, so for your first run, you can leave this file name alone, but then if you do a second model, you got to change it to something else. So you create a new joblib file. Okay, that's very, very, very important for that. JRB, you want to walk through the funky math that you wrote here for us?
Well, it's essentially a straight line port of Michael Oliver's code.
Okay.
So I think you might want to open his forum post first, and we could probably walk through that. Or you could have Michael Oliver walk us through it.
Yeah, well, maybe that's the best way to go. So the
Is that okay?
exposures, this exposures block does look pretty much the same as what's in the forum. It takes the x equals x minus the mean.
Yeah, it's essentially Pearson's correlation coefficient. That's what it is.
Yeah, that's exactly just Pearson correlation.
Okay, so it's just a longer script version than a convenience pass that we get from the metrics, because you have to do that for this function.
Yeah, because that's what you're trying to reduce, right?
Right. Okay. Cool. What is this experimental relax shapes function deal?
Oh, yeah. So the length of each error is going to be different. And so the XLA compiler, that the tf.function decorator essentially jits the function. And so that's where you get all the performance from.
Okay.
So by default, it essentially uses the shapes of the tensors that you pass in as guards. So if the shape of the tensor changes, it'll have to reject the function again. So this experimental relax shape says, okay, don't worry about the shapes. Use the same code over and over again, because there's no point in rejecting the same code over and over again for different errors.
How much performance boost do you think that gave us?
I don't know. I didn't measure either, but
I was just curious if maybe
it should be something.
Well, it is something. Yeah. Like I said, I have similar CPU runtimes as GPU. All right, so these are the different functions that are necessary to achieve it. Now, in the train loop, this is where the status bar comes into play. So I've run this before. For each era, it kind of gives you an update. How long does it take per iteration, which is how many iterations per second? That's what it's calculating. And it tells you. When I run it, I have like 21 seconds on average per era. And of course, there's a lot of eras to be done. However, since this gets cached, the first run's the longest. Everything after that is actually quite quick. So what I would recommend folks do is run this locally, save that joblib file, pass it into your compute folder, and then have this whole structure in your predict file. And so it pulls in the correct cache file, and then it will run very fast, relatively, of course, to having to do it from scratch inside compute. Although, if you do happen to not run it locally and you pass this in, as long as you have the cache file names correct, the first time will take a very long time, but then every subsequent week thereafter, it won't be nearly as long. So the first run is always the longest if you use this particular notebook for your production code. Okay, now the actual part that we need to modify, should you choose to, is in the max underscore exposure. I assume that EXP stands for exposure. And right now we have it set to Michael Oliver's predetermined 0.1 level. And I put a comment here so that you'd see it. Hopefully you see it when you copy it over, but select your maximum feature exposure here. Okay, so you change this number.
One thing I should say, that loss function in the train body loop is the thing that, with all those ReLUs. That's the kind of, in a way, the most interesting part of this, because that loss function is what is making it so that it's only reducing feature exposures. It's only targeting to reduce feature exposures above the threshold you set.
Well, walk me through that then, because I can't possibly explain this to the folks. I am unqualified to do so.
So I think you're going to start with target exposures.
Yeah. So the
introduce exposures.
So the target exposures is that's taking the like the top line, because basically the two parts of it are the just for the positive and negative component. So if you understand one, you understand the other. So it's just taking the difference between the positive exposures of your actual model and your and the target exposures, which is just the, let's see. So you basically, you start by calculating your target exposures, which are basically just the max of your current exposures, or sorry, the minimum of your current exposures and your target. And you're basically just calculating the difference between your current exposures and the target exposures. And so you only, that cost function is only positive when your current exposures are exceeding your target exposures. And so the target exposures are basically just a clipped version of your current exposures. So if you have an exposure at 0.5, so like 0.05,
Okay.
you're only penalized for going above it, but not penalized
Right.
for going. So it basically, your cost function returns 0 as long as you are below your 0.05. And it's making it so, because I found in an earlier version of this, if I just sort of clipped the so that the max exposure was say like 0.1, it would increase your exposures to other features.
Yeah.
And so I didn't want to take on any additional exposures. So you're basically always reducing or keeping your exposures the same.
That's a pretty big takeaway right there. Can you put it into words Arbitrage can understand? Because I think I got the gist of that, but I want to make sure that.
Sure. So yeah, so
definitely got the gist of that.
basically just think of a vector of your current exposures. And so it's just like it's going up and down. You have positive exposures and negative exposures, just your correlation with everything. And so it's, say your highest exposure goes up to like 0.2. And you have some that are like up 0.01, some 0.05. Basically, it just is clipping it at your target. And so your new exposures will be either match exactly the same as the target or lower across everything. And so it's just making sure all your exposures are either at their current value if they're below the threshold, or at the threshold.
Okay.
Yeah, so this is what you said initially, right?
Mm-hmm. I'm just making sure that
which is-
everybody else has it. I'm kind of giving people.
Yeah, which is that if the exposure for a certain feature is already below your threshold, it makes sure it stays that way.
Right.
Yep.
Yeah, and make sure it doesn't go, because like if you don't do that, an exposure at like 0.01 could go up to your threshold of 0.1. Just and that might be you can find a solution like that will do that, but this is just preventing it from taking on. You don't necessarily want to increase your exposure like that.
Right. Now, just a real quick aside, the regularized OLS models that we talked about last time potentially do increase exposure in other coefficients because it's touching everything. True or false?
I don't think they will actually ever increase exposures.
Okay, well, that's why I asked the question.
Yeah,
I wanted to make sure that.
This is much more of like, this is basically finding an arbitrary linear model that does something. And so if you
you're using gradient descent, right? And gradient descent has one purpose in its life, which is to minimize the loss function, right? And it will cheat if it has to do it. So one of the ways it can cheat is by increasing exposure for features which are currently doing all right.
Okay, cool. So that was the section of code in the train loop body that we're talking about now, correct?
Yeah.
So then here I was saying how these are the print statements that you'll see when you run it. It's a status bar and it shows you how many eras are remaining. So it gives you some indication of how much time is left. And I thought that was a really nice touch, JRB. Thank you for adding that, because you're kind of blind to it unless you add something like this to your script to show what era it's on out of however many eras. Like I said, I got to like 21 seconds per era. I'm using a Ryzen with 12 cores, so your mileage may vary. It could be very long. If you have a CUDA implementation that is installed working correctly, unlike me, feels bad, man. But you may have
might do
faster
much better if you have a newer Intel processor which supports AVX 512.
Feels bad, man. So what I'm saying is you could have a very long runtime, or you could be very quick. I was just telling you my benchmarks in case somebody has a similar machine to me. Your mileage may vary. I will just say Michael Oliver's script is great, but it took a very long time on CPU, and JRB's improvements, I think, take it to the next level. It is much faster. So try both if you want. The way it solves should be similar, and you should get the same result. But again, I want to let me hop back to here. Select your maximum feature exposure. So you really should look at your model before you neutralize it. You should see what your maximum feature exposure is anyway, because if it's something that you think is acceptable, maybe you don't have to neutralize it. Maybe. I don't know. I'm just suggesting take a look at it, see how your feature exposures look over time, and then make a decision. But yeah, so your mileage may vary. Do your homework, etc., etc. Okay, so JRB, this is where your cache file comes into play, correct?
Mm-hmm.
So what is it doing? What is it doing?
So the cache is essentially a dictionary mapping between the error name and the weights for the linear model, which is essentially a vector of 310 coefficients.
Right. Per era. It's looking to see if there's already a solution in the cache file, correct?
Yeah.
So if there's a solution already there, it doesn't try to run and find a new one because it's already found. That's the benefit of running it once locally, because you're probably going to have a faster runtime on your local machine than on AWS. If you don't, that's still fine. It's just going to take a really long time. Honestly, if you have 15 models and you try to do this on AWS, you probably won't be on time. Okay, so that's the caveat I'll throw in there. You're going to want to run it locally if you have a bunch of models. So yeah, what it's going to do is it's going to neutralize to you the exposure threshold you choose, save the coefficients in the job.lib file, move to the next one. In a week, when you call up this file again, that's what's going to happen. It's going to look in the job.lib file, are the coefficients stored? Yes. Okay. We don't need to solve it. Let's move to the next one. Oh, here's a new one. Let's find that solution to get the feature exposure correct and move on. So that's what's happening. And also, it's not saving error X. This was added fairly late in the process, but one that we found and fixed. So it will not save error X because every week that needs to be done fresh. All right. Is there any other important part that I may miss if I just move down a bit? I think I'm good, right, JRB?
No. Yeah, I think a Gaussianized part comes from the analysis and tips notebook.
Okay.
The example scripts repository. So
okay.
Yeah, it's fairly standard. Nothing out of the ordinary.
Yep. All right. And here we're actually neutralizing it and appending it. Okay, so that's what this last piece does. And then we're saving it as predictions. And so return predictions. That's the data frame that you need back so that you can save the CSV file and upload it to the tournament. This was something JRB helped me with because I said, hey, I'm afraid to update my CUDA so that I can make it work on GPU. So we try to maximize the number of CPU threads used, and this kind of achieves that without going crazy. So it doesn't overwhelm your system. I noticed that I never really had a lot of threads running at the same time because it was relatively stable and fast, but that's what this section does. So if it can't find a GPU, then it's going to try to optimize the number of threads available to it. So that's what's happening here. And then to actually execute it, like this whole block of code, this one cell downloads the prediction file or opens it if you have it locally. Remember, you got to match this to the top. That's why there's a little bit of work to be done before you can actually turn this into a production notebook. But in this case, it's going to download the example predictions from Numerai's AWS S3 bucket. It's going to download the tournament data file from the same place, and it's going to merge them together. So it gets to full _df, merging tournament and the predictions, right? So you execute this cell, and the next one is what actually does the work. So neutralize data frame is equal to the reduce all exposures function. All right, we pass that in. Why does my screen keep jumping? Pass that in, and it gives us back the neutralized data frame that we need. And we need to save that neutralized prediction to either local or the temp file in your compute architecture and upload that. That's what you upload for the tournament. And we just named it neutralized predictions. Okay. That's the whole notebook. And if you need to plug it into your production code, especially if compute, it's going to make your code fairly long, but really in the end, you're doing these final lines once all these blocks are stored for your use. And remember, you got to change the prediction file and the cache file name each time so that it runs. We have a couple questions that are being asked. Why half the CPU count?
Oh, that's because if you have hyperthreading enabled, and I believe this is the case with most computers these days, os.cpu count gives you the number of logical cores, which is twice the number of physical cores. So you want to
Got it.
use the number of physical cores, right?
Okay. And it says using the actual number of physical CPU cores instead of virtual threads was AI Joe's guess, and that was correct, AI Joe. Good job. And why do we need the example predictions? Well, in this case, to answer your question, the reason we're using the example predictions is because it's just plug and play. We're just giving you a framework to follow. If you run this with the example predictions, all you've done is neutralize the example predictions to a 0.1 threshold. And so you need to replace where it says example predictions to your own file if you want to do your own prediction file. This is just so you can see that it works. Run it on the example prediction so you can get familiar with it, and then do it on your own, or interrupt it after a couple of iterations, whatever you want to do. But this will work if you have it local and you download their prediction file. But you need to change the paths and everything else on your local machine. And then again, if you pass it over to compute. So that's what this notebook does. This is a framework. You shouldn't, I doubt that it would work, honestly, if you just run it as it stands. Maybe you'll get lucky if you have all the dependencies ready to go, but you'll have to check that out as you go. And the reason I said that, we're dropping the mic here. I guess I can stop share. Hold on. Let me get my, let's go to gallery view. Who's with us today? We have Mr. Braga. Thanks for joining us. Howdy. So we're dropping the mic on this because there's really nothing left. We've shown you different ways of neutralizing. We've talked about different thresholds, different exposures. It's time to get to work, folks. It's time to do your homework and figure out what threshold works for you, whether you neutralize or not. Is the risk acceptable to you if you don't feature neutralize? I honestly can't think of anything left after we provide this to folks to be done with feature neutralization. Michael Oliver, are we at the frontier here? Have we eclipsed all possible neutralization methodologies? Please say yes.
I mean, if you wanted to do something super fancy, you could try to use a differentiable version of Spearman and try to reduce that rather than Pearson or something crazy like that. But
I think we're there. I think the marginal utility that we can gain from doing such a thing is too small when we don't even have our thresholds.
It should be fairly straightforward to plug in a differentiable version of Spearman into this if you really want to. It's just that it's going to be so much slower that I don't know if it's really worth the trouble.
Right. 80-20 rule, folks. We don't want to spend 80% of our time on a 20% improvement, and I don't even think that's what's left. I think we're really there. It's picking the threshold that you're comfortable with, trying different levels of thresholds on the same model, and looking at it over time. Like the same thing I'm doing with the Twitch example models, one that's not neutralized, one that's at 50%, one that is at 100%, and seeing what it looks like over time. You should do that too. We're given 15 model spots. Imagine that you had 3 good candidate models. You could do 5 total different runs of feature exposure and test that over time. And then you can stake on the one that you think is the best for your risk tolerance level. I think that's probably a best practice. Would you agree, Michael Oliver?
Yeah.
Yeah. I mean, what would be left? I mean, you're kind of testing it in production. If I were to look at your models and seeing the 0.1 and the 0.05, and then the other one that's not quite, you believe in it because you're Michael Oliver, for goodness sakes. So you're still doing it. And I think that speaks to the methodology. I'm feature neutralizing some of mine unless they already have feature exposure that's not quite there. JRB, are you doing feature exposure in some form?
Yeah, I think this particular technique is really cool because you can essentially say, I don't want my model to be more exposed than a certain value, right? If you're essentially using the old linear model based thing, then, well, this is a linear model as well. You probably experiment with a bunch of different thresholds and things like that. But why should you experiment? Why don't you just let an optimizer figure it out for you?
Basically. So I think the open question is 0.1 the optimum point, or is it slightly higher than that? And I think that's going to vary person to person. But 0.1 is going to reduce your exposure to a level that probably reduces the volatility enough to be quasi-optimal. But Mike Oliver, you did that on your own model, so it really is subject to person-to-person experimentation, right?
Yeah, for sure.
Okay, that's a very fair
honestly,
thing to say.
I think it's somewhere between 0.1 and 0.15.
I tend to agree.
Yeah.
I think it's anything above 0.15 I'm a little nervous about unless it's really, really close. I might not neutralize that model. Can we talk a little bit about MMC, or do I not want to open that Pandora's box? They're both smiling. I'm not sure they want to even talk about it. MMC is dependent on other models, correct?
Yeah, for sure.
Yeah. So, JRB, you're the one in the forum post that said MMC helps everything it touches. Do you want to take that statement back?
Okay. So I just signal boosted ButtBots meme that. So he's the one who posted the meme, and yeah. So the meme was that feature neutralization improves MMC for everything it touches, and I'm not so sure about that. And if you look at the performance of ButtBot 7, I'm sure you'd agree. So yeah, you should probably take a look at it.
Well, in this current regime, I think that's what Michael Oliver was saying, that this is odd, that feature neutralization shouldn't hurt. It didn't before. I could feature neutralize and didn't exactly hurt. It may have reduced my correlation some, but now it seems like in NOMI, and I think that by itself is spurious correlation. I don't blame NOMI for that happening personally, but we get into the 240s, and all of a sudden, if you feature neutralize even a little bit, you're getting killed. That's just very strange to me. And you're saying that just is kind of like a regime sort of shift, if you will.
There's clearly some features that are working really well right now.
Right.
Like the number 4 person. I mean, you can sort of tell this, you can infer this just by looking at their correlation and MMC rank and their feature neutral correlation rank. Their core rank is 4 and the feature neutral correlation rank is 825. So clearly there's some linear exposure that is helping a lot.
Okay. I think that's definitely fair. So help me understand why I can have a top 5 FNC ranked model and basically not earn any core. That kind of like feels bad, man.
Yeah. I mean, it's I mean, that's what will happen if like the current regime can be explained by a linear feature pretty well.
Yeah. It's just kind of like, it hurts. Just saying. Because I can't stake on FNC. I wish I could. There is a question that I'd like to pass on. Feature neutralization tinkers the validation or test data directly, which violates a basic machine learning rule: don't tinker with test.
It doesn't. It's only affecting your predictions, and it's not looking at.
Right.
Yeah, it's not. This is. Yeah, it's. I mean, it's similar to any kind of other regularization parameter thing you are doing that is distorting your predictions.
And it's ex post anyway, so you're not learning.
Yeah.
We're subtracting. We're literally taking out something. Now, I don't think that would qualify quite as a violation of anything. That's my opinion. I reserve the right to be wrong, and if I'm wrong, I'll blame Michael Oliver. Seems to work pretty good. There's another question for you, Michael Oliver. What's your take on the significance of introducing feature neutral correlation as a metric?
Yeah, I mean, as of now, we just think it's a useful metric for people to see and be able to see in other people. And that's about it.
Just like how you did with the number 4 model, you said that they have a 4.2% correlation and a 1.4% FNC. All their rank is in correlation is coming from some linear exposure.
Yeah.
Right.
And so it's just an interesting metric and useful metric. We think it's an important metric for people to pay attention to. And I think you should feel pretty good, especially long term, about having a good FNC. and know that if your rank on that is pretty bad, you're likely to have some hard times ahead.
That is very interesting. That sounds like a prediction to me.
I
I'd like to
mean,
revisit this in like 3 months.
I mean, yeah, who knows how long a
Right.
given feature will work for?
Yeah, we have no idea. Literally, this could be a regime change, not a shift. We don't know, and we won't know until we look back and say that that's what happened. There's another question: is there a plan for people to stake on FNC or FNC plus MMC, 2x FNC, et cetera, et cetera? Like, is there any plans on doing something with FNC?
No, there's
No.
no, I know.
No. The answer is no. Okay, cool.
Yeah.
Figure we out. I'm gonna do it, fam. Michael Oliver, what are you working on?
Yeah, I'm always working on different ways. Well, yeah, a bunch of different things. Working on new targets. Eventually for our next big release. Working on just making our optimizer, our portfolio optimizer better. Because we always have this. There's an issue of translating from the signals we get from all of you guys and aggregating them into actually building a portfolio. And there's a lot of things that go into that. And so, yeah, that's one of the big things I've been constantly working on is just making that better.
Very cool. Thank you. I know I definitely put you on the spot on that one. And I try. You can always say no. I'm not talking about anything, but I appreciate you let me get away with that. I guess I'm going to say that I pretty well covered feature neutralization by this point. I honestly don't know what else we could cover with feature neutralization, except that Michael Oliver suggested that you take some kind of plotting mechanism and look at the feature exposure in terms of like a heat map. That's something that I haven't toyed with. I don't really, I guess I don't agree with you, Michael Oliver, that that's something that's worth doing because I don't want to know exactly which features I'm exposed to or not.
I think it's I think it's useful for a couple of reasons. It can show you when your feature exposures change over time. So I think there's some really interesting things that like happen if you basically plot it against all the validation eras. You can see that that your feature exposures are very different for the later validation eras. And this is one of these things that's a little bit kind of interesting because these are your out of sample feature exposures, and your out of sample feature exposures are always higher than if you basically train a model to have very low feature exposure in sample, there's no guarantee it'll have low feature exposure out of sample.
That's fair.
And also seeing how your distribution and the features you're exposed to can change from eras 120 to 132 and then into the later validation eras. It's good things to be aware of how things will behave out of sample. And it also sort of shows you whether or not your feature exposure is sort of balanced or not. Do you have lots of features that have relatively the same amount of exposure, or you just have like a small feature group that is taking on all the exposure?
That's a good point.
These are all things that I think are useful to be aware of.
Yeah, no, that's a good point, because if it is some subset of the features and it's consistent through time, that's probably not very good. You want some variation there. That's a good point. And it's intuitive when you say it out loud, but I didn't really think about it. But you could train it to have some max feature exposure, but it could still have out of sample feature exposure. I didn't really think about that. That's true. That's possible. So I guess if you train it to have some max feature exposure, you should probably clip it to that too.
Yeah, pretty much the only way to constrain the feature exposure out of sample is doing these post-hoc things. Because the input distribution to these models changes, and we're pretty much always in a different regime than exists in any of the training data. And which is that's why it's so hard and so fun. But
indeed,
this is why we need more training data.
No, I don't agree. I'm just not going to agree to that.
I didn't say more features. I said more data.
We haven't explored the space on feature neutralization or doing a feature neutral target. That's something else we talked about. And yeah, we have so much more that we could do. I honestly don't agree with you, but you know, that's okay. We're allowed to disagree. That's what makes this place great. You know, we all have different domains, knowledge, and different priors, so it's awesome. There is a question: can max feature exposure be a random effect? Example: max feature exposure of 0.2 can be a random effect, but we try to hammer it within a certain limit, say 0.01. What are your thoughts on that, Michael Oliver?
It's usually not. Like if you looking at that sort of across time, your highest feature exposures will be consistently your highest feature exposures in different eras in the future. So, and it'll bounce around a little bit, but it's always going to be a very high feature exposure for one that you have a lot of exposure to. So the actual value is probably a bit random, but whether or not it's pretty high and you would want to reduce it is, I would say, not.
Okay. Well, like I said, just a question. Yeah. So that's it, guys. Folks, guys, everybody, that's it. We have covered it. Feature neutralization, feature exposure. The frontier is there. The marginal improvement to be gained is on you. So now we need you to go out and try this on your models so that we can reduce the volatility of the predictions that we're submitting to the meta model. We want that positive feedback loop to kick in. And the reason that they being Numerai, they have focused so much effort on feature neutralization is because it's important. JRB brought this up last time. He says, you know, often when Richard says something's important and we don't do it, they force us to. So we don't necessarily want to be forced into this. I would recommend that we all try it a little bit and see what we can come up with. I think we can probably trace some improvement in the meta model to all of this work on feature neutralization, such as what came from the fireside chat. I'd like that to be true. I think we can make it true if we all just spend a little bit more time and explore our sensitivities to feature exposure. So that's what I have for you today, folks. Thank you all for tuning in. Special thanks for JRB for helping us put together that notebook with the caching. That to me was a big innovation, and I think it's going to save a lot of people a lot of time once you get this running. And do thank him in RocketChat, and when you see him around and about, especially if you're in his town, buy him a pint. I think he earned it. And Michael Oliver, thanks again. Big help. I'm a little sad that it took 5 months for us to circle back and get to your feature exposure clipping tool, but now we've done it, and that's it, guys. Everybody, we're dropping the mic. We're done. This is it. Boom. Go home and work on your feature exposure. That is your homework. So I'm John Taylor, known as Arbitrage. Thanks again, everybody. Have a great day.